Hey guys, welcome to this new video about hockey scraping, NHL scraping data from the NHL Api. And in this video, I want to talk about a new scraper that I've created. So if you like this video, you should absolutely consider hitting the subscribe button. But other than that, let's just get started. So you can find the new scraper if you go to my website, hockey-statistics.com, and just hit the scrapers button in the menu section. So in this video, we want to talk about the game scraper. So let's just try and download that one, and then we'll go through it step by step. So let's just open it. And that's it. You have to enable editing. You also have to enable data connections because we're getting the data directly from the NHL API. So we'll just say enable content. And then this is what it looks like. So the scraper scrapes the output files in this scraper is 4 different tables. You have the player data, you have the shift data, you have the play-by-play data, and you have the game data. So we'll go through it step by step. But let's just start off by scraping some data. So we could select the December 14th, last night's game. And then in order to scrape the data, we just have to hit the refresh all button. So scraping the data takes a short while, depending on the quality of your computer, depending on how many games are being played that night or in that date range. So it will take somewhere between 30 seconds and 2 minutes, depending on your computer, depending on how many games you're scraping. But it is getting all the data from the NHL API and then transforming it and combining it into these four tables. And this is it. So now it's got the data from the 14th of December. So let's just go through it step by step. So the first table we're getting is the player table. So it's pretty simple. It's just the player ID and the name, position, if the player shoots left or right, for all players that has played at least one game in this season. So you see Corey Perry here is not currently on any team. So that's what the data looks like. It has the nationality of the player, it has the birthday of the player. One thing we could try and just illustrate is you could add things to this table simply by adding a measure. So we could try and add a measure and say we want to calculate the age as of today. So that would just be today, which just gives us the date of today minus the sum of the birth date. And this will give us the age in days, but we are interested in the age in years, so we could just divide it by 365.25. And then maybe we want just one decimal in the number. So we could, this is just to try and illustrate how you can add things to the tables that we are scraping. So now we have a function down here that's called age. We can just add it and it calculates the age of each player as of today. Again, if you want to add measures, it requires just a little bit of practice. It's written in the language called DAX, but it's not too complicated once you get a hang of it. This was just to illustrate that you can easily add measures if you want to. So I don't want to talk anymore about this table. It's really simple. It's just the player IDs and the name of each player. that has played in this season. So let's go to the shift data table. So in this current setup, in this default setup, we have one row for each player shift. So we can see here that Brent Burns played in the first shift, and that shift lasted for 32 seconds. The start index is just the first 5 digits of the game ID, and then the time is the 4 last digits. So it started at 0 seconds and ended at 32 seconds. So in this setup, you have one row for each player that has a shift. Now the shift changes every time at least one or more player make a change. So this means that Brent Burns may play multiple shifts in a row. So you can see he plays the first shift, he also plays the second shift, and then he gets off the ice. So he gets off the ice after 35 seconds, which actually lasts two shifts. So this is the default setting of how the data is set up, but we could even set it up differently. So instead of having one row for each player shift, we could have one row for each shift and then have the players in different columns instead. So let me just try and illustrate that. So we'll just defer layout, and then we'll just remove everything that has to do with the players. We'll even remove the string state. Yeah, so we could do it like this, say update. So now it just gives us the season, the game ID, the game date, shift index, start, the end, and the duration. So now it's just one row for each shift. So you can see the shift just counts upwards. So now instead of having a row for each player, we have a row for each shift. Then we could add, let's say, the string state of the home team. I'll just remove this one. String state of the home team, string state of the away team. And we could add the home players. So this is the player ID of the first player, second player, third player, fourth player, and so on. So now you have all the information not in each row, but in columns. And we could do the same for the away players. And we could even add information about the forward lines for the home team, defensive pairings for the home team, the forward lines for the away team, defensive pairs for the away team. And then we could just maybe do this a bit nicer. And we could make this a bit larger. So here you can see that for the home team in the very first shift, you had Daniel Sprong, Rasmussen, and Berggren on the ice together. And you can see the same for the away team, and so on and so on. So this is pretty cool, I think. So whether you prefer the number one setting or this setting really is up to you. I think it will be slightly slower to load this because there are more meshes to be calculated, but other than that, I don't think there's a huge difference. It depends on how you're using the shift data. So then we'll go to the play-by-play data. Again, getting the data from the NHL API. So in this default setting, I'm just including shots. So it's only including block shots, goals, missed shots, and shots on goal. But if you wanted to have more information, you could add penalties, for instance. And now you can see there's a penalty added here. Yeah. But again, it depends on what you're using the data for. You could even add other things, obviously. So in this data, you have more classical, just play-by-play data. You have the season, game ID, date, event index, just counting up the first 5 digits stem from the game ID, the last 5 digits of the game ID, plus just the number of the event. You have the time. Again, I'm using the first 5 digits is representative of the game ID. And then the last 4 digits represent the time. So this is 50 seconds into the game. You even have the shift index. So there's a connection between the play-by-play data and the shift data. So this is the third shift of the game. So we can go here and see 50 seconds into the game should be the third shift. So that's this shift, which goes from 35 seconds to 64 seconds. So that's obviously the third. So 50 seconds is obviously within that time span. So this means that the two are connected, the play-by-play data and the shift data is connected. Okay, so other than that, you can see the shot time, you can see the away team, home team, the event team, the whether or not the event team is also the home team or not. You have the strength of the event team. That's important to understand that. This is the strength state of the event team. So this is the strength state of Carolina in this case. And I also have the strength state in even strength, PP, or shorthanded. Then you have player 1, player 2, player 3. That's just how it's usually set up. So player 1 is always the shooter or the goal scorer or the winner of a face-off, for instance, or the penalty taker. So in this case, you have this player is the player committing the penalty. This player is the player drawing the penalty. So player 2 is the shot blocker. It's the primary assist maker. It's the loser of a face-off. And the third player is the secondary assist maker. So this has to be a goal with this guy having the secondary assist. And you can see here it's a goal. Okay, then you just have the position of the position of the event. You have whether or not it's a Corsi, Fenwick shot, or a goal. And you have the XG value. So in my model, there are 2 different XG models. So you have a XG model based on Fenwick's. So this is more of a classic XG model that uses all on-block shots. But I also have an XG model based on shots. So I'm using this one for all play driving metrics, XG percentage, and so on. And I'm using this one for goaltender metrics. So I don't want to give credit for shots that misses the net. I don't want to give credit to the goaltender for those shots, if that makes sense. Finally, we could add a few things. I just want to illustrate that in the data I've already calculated some meshes. So if you wanted on-ice information, we could just add these. And they will show who's on the ice for the event team. Player 1, player 2. And this takes just a little bit of a while. So let's just defer it. Again, I've elected not to include these in the default setting just because I'm not using it and it will take a little bit longer to scrape the games if you have these measures included. Okay, so now it's loaded and you can see information about all the players that are on the ice for each event. Depending on what you're using the data for, it's up to you if you want to have this data included or not. Now, maybe the final thing I could show you just again to illustrate how you can use meshes to add things to the scraper. So maybe we are not interested in having the player ID here, but we are actually interested in having the player name instead. So let's just try and calculate a measure that looks up the player name instead of the player ID. So we'll just add a measure. We could call it player one name. So in this case, there will be two ways you can look up the name. The easy way is to just use the lookup value function. So then the one thing we want to look up is in the player table. So we'll say players, and we want to look up the name. And the column we want to search is the player ID column. So it's again players, player ID. And the value we want to look up is the sum of the play-by-play data, play-by-play table, and then the player one. Then we'll just end it like that. Okay, so now we have the name of the event player, the player one, instead of having the player ID. And you could add names like this, but again, you just need to be careful about how many meshes you add because it will slow down the scraping process. So if you have a really fast computer, you could add many meshes. If you don't, I really do not. You have to be careful about how many meshes you're adding. Again, this was one way you could calculate the name, or you could find the name. I used the lookup value function. It's probably preferable to be using the minx function, but I don't want to go through that today. That would probably be a bit faster, I think. So this was just to illustrate how you can add things to the scraper as you like. Now, the final table in my scraper here is the game data table. So what we have here is we have information about each player for each game. So one row is the performance of one player. So in this case, you can see Brent Burns, got information about him. He's a defender. And in this game, he was playing away and he got 13.8 minutes of even strength time on ice. Then you have on ice information. All this data here is information about what happened when Brent Burns were on the ice. So you have the goals for, goals against, you have the expected goals for using the Fenwick-based model, you have the expected goals against using the Fenwick-based model, and you have the expected goals against using the shot-based model. Then you have Corsi for, Corsi against, Fenwick for, Fenwick against, shots for, shots against. So all of these are on-ice statistics. Then you have the individual statistics as well. So this is how many goals did he score at even strength, how many primary assists, secondary assists, individual expected goals using the Fenwick-based model, Corsi for, shot attempts for, Fenwick for, individual shots, how many penalty minutes did he take at even strength, how many penalty minutes did he draw at even strength. And then you have all the same data but on the power play. So he played 3 minutes of power play time, and this is the data. And then finally you have the same for shorthanded. He played 2.7 minutes shorthanded. Okay, so that's what the game data table looks like. So I think this is a pretty cool scraper. Now, it does take just a minute or so to scrape the games, depending on how many measures you have and depending on a lot of things. But you can set it up the way you want to. So for instance, if I'm not only interested in the game data table, I can just delete all the other things. So let's just try and delete all of these. We don't need them. I was just interested in the game data. So now we can try and refresh the data, and we'll just refresh this table. This should make it slightly faster because you don't have to calculate any measures from the other tables. Now, it will still take some time because you still need to have the shift data, you still need to have the play-by-play data in order to calculate this table. So the retrieving of the data should be close to the same time, but it will read the data faster. So my whole point is that you can set up the scraper whichever way you want. Some of it requires a bit of DAX knowledge, but it's not too complicated, I promise you. So now it's just loading the data once more, loading the game data. And again, it will take maybe a minute or so to do so. So there's a lot of things going on behind the scenes that you don't really see in this scraper, but this is why it takes some time, because there's a lot of things going on in terms of calculating the XG values, in terms of combining the play-by-play data with the shift data and converting the shift data into something that you can use. But again, this is how it works. Now it's loaded once more. And as you can see, my computer is a bit slow. That's because it's 5-6 years old. But even on my computer, it doesn't take more than an hour or so to, a minute or so to load 1 day's worth of games. So I hope you enjoyed this video. I hope that you can use this scraper. I think it's pretty cool, and I promise you that there's no publicly available scraper that can do this many things. So I hope you'll use it. I hope you'll subscribe to my channel, and until next time, see you.